Hi everyone, in this lesson we are going to talk about the acid-base equilibrium from the point of view of the four different points on the curve. So as long as you understand these four different points on the curve, you will be able to understand this whole chapter. Alright, so let's start by asking ourselves the very crucial question whenever we tackle acid-base equilibrium questions, which is this question of what is present. Alright, this is always the first question that I ask myself every single time I tackle the question. I will ask myself what is, after I pour everything in, right, at that point in time, what do I have left? So over here we have this equation of ethanoic acid and our sodium hydroxide, and this will give us our ethanoate and water, of course. Okay, so what we want to do is we want to be able to identify what is present at each point in the graph, right? So the first thing that we will notice is that on this graph, when the volume of NaOH added is 0, we only have ethanoic acid here. So this is point number 1 of the graph. And there should be a pH at that point in time. Okay, and as we add more sodium hydroxide, it's going to go up, flatten, and eventually it's going to shoot up. Alright, and this is the equivalence point where our NaOH and ethanoic acid is in 1:1 ratio. Right, it's perfect. It has reached its equivalence point, and so the only thing we have here is our ethanoate and water, nothing else. Okay, but what happens before equivalence point, after equivalence point, is another thing that we need to talk about. So before that, you'll notice that the one that's in excess is our ethanoic acid, because we wouldn't have added enough sodium hydroxide yet. So if we have so much ethanoic acid and we keep adding sodium hydroxide, it starts consuming ethanoic acid bit by bit, alright, while forming your ethanoate. Okay, you'll notice that this is our remaining ethanoic acid, this is our ethanoate that is formed. Then you would realize that from here to here, alright, to our equivalence point, which I'll call it point number 3, we have a mixture of the acid and its conjugate base, which is the ethanoate. And I hope you are able to see that this second point means that it is a buffer solution. What kind of buffer is it? It is an acidic buffer. Okay, so then what happens after this graph? So this is from here on, it is point number 4. What we have is we have the ethanoate present. Okay, since NaOH is already in excess, all of my ethanoic acid has been used up, so all this is out. Now I have one whole graph of one whole unit of sodium ethanoate. And now what is going to happen is that any additional sodium hydroxide that I add in is going to contribute to this increase in pH. Alright, so that's why towards the end this is the pH of a strong base, which is predominantly NaOH, but it will never be as high as our concentration of NaOH if I were to add the pH of just pure 0.1 mole NaOH. So these are the 4 points on this graph that you need to know. And so ultimately the question that you need to ask yourself is what is present at that point in time after the reaction. So let me go through again. At the start, you only have the acid, the weak acid. As you add NaOH, you get the buffer solution, right? At equivalence point, you get the salt, and then at the end you only have the salt and the strong base. So usually we are not required to calculate things here, but we are required to calculate this value here, and this values here. Alright, so in the next video we will talk about how we can go about calculating these values.